Hi, my name's Mark Higgins. Welcome to EUMETSAT and welcome to the first of our weekly feedback videos. I really hope you've enjoyed week one of the course and you've enjoyed looking at the whole range of satellite data that we have available for monitoring the oceans and got a feel for some of the things we can do. During the course of these weekly feedback videos, what we'll be doing is looking at some of the questions you've been asking in the forums, giving you some feedback and showing you some examples from other things that are going on right now. So let's turn now to some of the questions that you've been asking in the discussion forums. So this first question comes from Gabrielle, who asks about two areas of satellite observation. First of all, salinity, which is really important for understanding density and ocean dynamics and the height of the ocean and circulation. So Gabrielle's asking, there are now satellite missions for salinity. What can they actually measure? So in this case, what those satellites do is they use microwaves that travel down to the ocean surface, interact with the first 2 centimeters and then travel back up to the satellite. And that's what we're looking at. We're looking at the surface salinity for these kinds of observations. So very much like the sea surface temperature, where you're looking at the surface layer, and you then need to combine this data with other data such as ocean height, sea surface temperature, any other circulation measurements you've got to build a full 3-dimensional model of the atmosphere. It's a really nice question. The other question Gabrielle was asking about was on the detection of icebergs. What's our limit of observation now? How small an iceberg can we see? The Sentinel-1 mission from the Copernicus Sentinel spacecraft, which is run by the European Space Agency. This satellite is a radar, so it's sending down radar energy onto the ocean surface, which then comes back up. And with this instrument, you can see icebergs down to 30 meters. So there's still quite some scope to increase the resolution and the size of the icebergs we can see. But that's been quite an advance. So now being able to see icebergs of 30 meter size is a great thing, especially for things like shipping. Lee was asking a question about validation. We'll get a lot more into this in the later parts of this course. What we mean by validation is checking that the satellite data that we have actually matches something that we can go out and measure in situ. So we go out with a measuring device, a thermometer, an optical instrument for looking at ocean color, and then we can compare what we can see from the satellite and what we can see using a completely independent measure to check that the satellite data is what we say it is. We'll come a lot into this in the later parts of this course. It's tricky and it's really important that we do this. During the course, we've been using these phrases level 1, level 2, essential climate variables, and this has been a source of confusion for some of you. So just to explain what we mean by this, when we talk about the satellite data, we can mean a wide variety of things. The levels just refer to how processed is it. Level 1 is the first step of processing. So here we have some measure of the satellite, a radiance or something like that, very much based in the satellite world. We then process that and change it into something that we call geophysical. So an environmental measure, a temperature, an ocean color estimate, something like that. And the more processed it is, the higher up the levels you go. Quite often, if you're wanting to look at a large area over large periods of time, what you're wanting is what we call the level 3 or the level 4 data, where data from many different satellite missions has come together to produce an integrated sea surface temperature measurement or an integrated ocean color measurement. The other part of Michael's question here is about the essential climate variables. So there is a very long list of variables which are considered essential for monitoring the climate, things like sea surface temperature, things like sea surface height. And what they provide is a user requirement for the satellite people to then produce data sets that can meet these variables. One of the really important things we need to do with these essential climate variables is reprocess the satellite data so that we've got a nice consistent record despite changes in the satellite, changes in some of the calibration parameters. Now we need to be really careful at this point because we don't want to introduce changes to the record that are actually more to do with the processing than the real environment. So all of those changes are publicized in the scientific journals so that people really know what has happened to the data. Transparency there is really important. So thank you for all of the questions you've been asking in the forums. It's really interesting to see them. In this week, we're going to move on and look at how we use satellite data in weather forecasting and weather prediction. It's quite an important part of the whole forecasting process to know just what the atmosphere and the oceans are doing right now. And of course, the oceans drive the atmospheric process. And we've seen that in the course of the last week. Right at the beginning of this course, we saw ex-tropical cyclone Ophelia, or ex-hurricane Ophelia, travelling up towards the UK and bringing with it some incredibly strong winds. As it travelled up, it wrapped in a whole bunch of warm air, and so we saw kind of really dragging up a whole set of warm air, and it made it very warm in Germany, France and Spain just as that cyclone was moving past. It's quite an interesting storm. As it's a cyclone, it's drawing energy from the water surface as it travels over this warm air. As it travelled up past the Azores, it then interacted with a cold front. It now moved over some slightly cooler water, no longer a tropical cyclone because it's not drawing its energy from that water surface, but it's still very energetic. And as it wraps in that cold front, it really gets tightly spiraled, really generating incredibly strong winds, hurricane force winds as it travels over. This is our storm season, so this will be quite an interesting time to look at the value of satellite data in weather forecasting. As we move into October, it's when we start to get those storms coming across the Atlantic and coming over to Europe. I really hope you enjoy this part of the week and do carry on discussing in the forums. It's wonderful to see.